Let's graph a parabola with its focus and directrix. In the previous grading, we were able to graph a parabola just from 5 different coordinates that were actually taken from our table of values. That was what happened during our grade 9. But for this grade level, we can also graph a parabola even without those points, just simply identification of the focus and the directrix. Please do not forget that the focus and the directrix has the same distance to any point on the parabola, and that they are just on the opposite areas of the graph. The focus is on the interior of the parabola, while the directrix is found on the exterior. Let's try to graph this. We have here this equation in its standard form. X squared is equal to negative 6y. For us to be able to graph this, let us not forget that we also need the vertex of the parabola. But for expression like this, or rather a standard form of an equation just like this, it is already expressed in the form x squared is equal to 4py. This form has its vertex already identified at the origin, 0, 0. Since we already have the vertex, we could plot it here at the bottom, and this is our vertex here. Or let's use the green color for our vertex. Now that we know that this is the vertex, take note that the vertex is also considered as the turning point of the parabola, because it is where the parabola changes its direction from a decreasing form of the parabola to increasing, or vice versa, from the increasing form of parabola to its decreasing form. So we already have its vertex, but then again, we need to determine first as next rather the focus and the directrix of the said equation of the parabola here. Since this form is already expressed as x squared is equal to 4py, we can just simply place it here. You have x squared is equal to 4py. And then, with the use of just simply comparison between the two equations, we can solve for the value for p. The value of p here will tell us how far is the focus from the vertex, as well as how far is the directrix from the vertex. So with the use of this, we have x squared here, y and y. We are left with this expression here, telling us that negative 6 is equal to 4p. And with this, we can solve for p by dividing both sides by 4. And the value for p is equal to negative 6/4, or in lowest terms, you have negative 3/2. This is the value for p. For equation like this, we already have a summary for that in our module. We can use this to get the focus. The focus is a point on the Cartesian plane. So this is also a combination of an x and y coordinates. Before we can identify the focus with the use of the value of p here, we need to also remember that if an equation of a parabola looks like this, the parabola could either be opening upwards or opening downwards. This is what happens if the expression with the second degree, or with exponent 2, is x. If it's y, then it would be sidewards. What is the point of identifying whether it's upward or downward? If it's upward or downward, the focus of the said parabola is located with the vertex at 0, 0, or origin. The focus is located here on the y-axis. Okay, why y-axis? Because if the parabola will be opening upward, the focus is somewhere here in the axis of symmetry. If the parabola is opening downward, the focus is also here. That's in the axis of symmetry. In this case, our y-axis. The purpose of also of identifying where is it located is for us to be guided that if it's in the y-axis, the value for x for the focus is always 0. And hence, the value for or the coordinates of our focus is at 0, p. And p is what we have here earlier. The focus is located at 0 and negative 3 halves. Let's plot this in this Cartesian plane. Let's just say for the purpose of um, graphing, let's just say that this is 1, this is 2. So let's not follow the one grid, 1 point, one step. Let's make it 1/2 per one grid so that we could plot here 1 and 1/2. This is earlier, this was our vertex at 0, 0. Our focus is now located at 0 and negative 3. Oops, that's negative 3 halves. If this is the area of the focus, we can now imagine that our parabola must be opening downward. Another help for us determine early that our graph is opening downward is by just looking at the value of the coefficient here. Since it has a negative sign or it's a negative coefficient, it should open downward. If it's a positive coefficient, it should open upward. So that be the case, we can also determine that the location of the directrix. Take note that the distance of the vertex from the focus is the same as the distance of the vertex from the directrix. And since it's three halves, it's actually three halves away from the vertex, our directrix should also be three halves away. Again, don't forget we're using here these two grids for one. So the directrix should also be here, just directly opposite the focus with respect to the vertex of the parabola. However, the directrix is not a point. The directrix is a line. And that line or that directrix is actually perpendicular to the axis of symmetry. The axis of symmetry here again is the line where our focus is located, and that is our y-axis. So our axis of symmetry here is considered to be a vertical line. So if we talk about perpendicularity between the x-axis or I mean right y-axis or considered to be the axis of symmetry and the directrix, if the y-axis or the axis of symmetry is vertical, then definitely our directrix is horizontal passing through this point. And we can draw here a horizontal line passing through point directrix, a point here. And this line here has an equation. If it's a horizontal line, its equation is y equal to the value where this line here intersects the y-axis, and that's actually 3 halves. Because the directrix is to be solved by, okay, for this expression, y is equal to negative p. Our p earlier is negative, so we have negative of negative 3 halves. Double negative property tells us that the equation of the directrix is y is equal to positive 3 halves. So this is our focus and this is our directrix. That's why we have this two. We have the directrix here and focus. And just to simply complete our parabola, because we are not asked here to show any points of the parabola yet, let's just simply draw a parabola that will contain the focus, but will not contain the directrix. So most probably, it will look like this. I'm not I'm just saying this is actually a raw graph because we haven't decided on some other values here, because that is only the concern here, only the focus and the directrix. Later, we might be asked to give other points, but as of the moment, this is our parabola. It opens downward as it contains, or the focus is on the interior, while the directrix is on the opposite side. Again, the focus and the directrix has the same distance to any point on the parabola, and specifically the first point that we could determine, the vertex. This is for this practice exercise. See you in the next one. Goodbye.